Problem 51. A system is described by a density matrix rho as given in the basis spanned by psi. Hilbert space is now projected to a subspace by an operator P in this way. In terms of chi, the density matrix for the projected system is, so the density matrix rho prime is given by, now we use this rule, which means this is equal to P psi I P, since P is Hermitian. So this can now be written as P rho P. Note that trace of rho prime has to be 1. So we calculate the trace of rho prime, which means P rho P, and this is essentially trace of P squared rho, and which is P times rho. So we divide this rho by this thing to make sure that the trace of rho prime is 1. So the density matrix should be P rho P divided by trace of P rho. So option C is the correct answer. Problem 52. A system can be either in the ground state or the fast excited state. The probability that it is in the ground state is given by Pg. The entropy would be maximum if Pg is equal to, we can write the density matrix rho as Pg 0 1 minus Pg, and the entropy is given by minus k trace of rho log rho, which essentially means minus k Pg log Pg plus 1 minus Pg times log 1 minus Pg. Next we find the derivative of s with respect to Pg, and this is given by log Pg plus 1 minus 1 minus log 1 minus Pg. We equate that to 0 and find this is equal to log of Pg minus 1 minus Pg, which equals to 0. So Pg divided by 1 minus Pg has to be 1, or 2Pg is equal to 1, or Pg is equal to half. So option C is the correct answer. Problem 53. For lithium, the Fermi energy and the electron density are respectively this and this. Then the electron density of a metal having Fermi energy this will be, we know the Fermi energy E is proportional to n, the number density of electron to the power 2 by 3, or E1 divided by E2 to the power 3 by 2 is equal to N1 divided by N2. So we find N2 is equal to N1 times E2 divided by E1 to the power 3 by 2. Now we put the values of these quantities. N1 is 4.6 into 10 to the power 28, E2 is 2.35 electron volt, E1 is 4.70 electron volt, and we find the value of N2 to be around 1.5 times 10 to the power 28 per meter cube. So this is close to the option given in B. So option B would be the correct answer. Problem 54. What are the eigenvalues of the operator sigma dot p, where sigma are the Pauli spin half matrices and p is the vector? So consider A as sigma dot p, and note that A squared, which is equal to sigma I pi times sigma j pj, which is equal to pi pj sigma I sigma j, and now we use this identity sigma I sigma j is equal to delta ij plus I epsilon I j k sigma k. Since this is totally antisymmetric and pi pj are symmetric, only the terms containing the delta function will contribute. So this is equal to pi pj times delta ij, which is pi squared, that means this, times the identity. Thus we find A squared is equal to mod of p squared times identity. So the eigenvalues of A would be plus minus square root of mod p whole square, and which is plus minus mod of p. So option D is the correct answer. Problem 55. Consider a particle of mass m in a two-dimensional potential way. Given by this, what is the energy of first excited state? We can write the potential V as follows. So half m omega 1 squared x squared plus half m omega 2 squared y squared, where omega 1 is 2 omega and omega 2 is 3 omega. We now know the energy eigenvalues. So these are given by two numbers nx and ny, and this is given by nx plus half h bar omega 1 plus ny plus half h bar omega 2. So omega 1 is 2 omega and omega 2 is 3 omega. So the ground state corresponds to nx equal to 0 equal to ny. To find the first excited state, we put nx to be 1 and ny to be 0 and find the energy. So E1 comma 0 is 1 plus half times 2h bar omega plus 3 by 2h bar omega, and this is equal to 3 plus 3 by 2 h bar omega, and this is 9 by 2 h bar omega. On the other hand, if we put nx to be 0 and ny to be 1, the energy would be E01 h bar omega plus 1 plus half times 3 h bar omega. This is given by 1 plus 9 by 2 h bar omega, and this is 11 by 2 h bar omega. So we clearly see that this is the first excited state. So option C is the correct answer.